The difference between what we did yesterday and what we're doing today is very little, actually. It's still the ratio test, but yesterday all we had were n's. Today we have n's and x's. Yesterday we decided whether the series converged or whether it didn't converge, period. Today we're going to find values that make the series converge. What values of x can we plug in so that it does converge? So that's the goal here today. Here's the first example. And when we do the ratio test today, we're doing the limit as n approaches infinity of the absolute value of this series. And since we're doing the absolute value, this -1 now doesn't really affect how we're going to do the problem. As a matter of fact, we don't have to consider it at all. And so we have x minus 2 to the n plus 1 over n plus 1, 2 to the n plus 1. So the ratio test says take the n plus 1 term and divide by the nth term. Now, since this is a fraction, we're not going to really divide. We're going to multiply by the reciprocal, which is really the same thing, over x minus 2 to the n. Now we just take it one piece at a time and cancel anything that cancels. The limit as n approaches infinity of absolute value, there's an extra x minus 2. So I take care of x minus 2. There's one extra on the top. That n plus 1 means one more. Then there's an extra 2 in the denominator. So I take care of the 2's by just putting a 2 in the denominator. And then the rest of it is just n plus 1. There's nothing I can do with the n's, not yet anyway. Well, now if I take the limit as n approaches infinity, I'm really doing the limit on that piece right there. That's a rational function. And the value of that is 1. So now we're just looking at absolute value of x minus 2 over 2 is less than 1. Now we're not deciding whether it converges or not converges. We're finding out what values of x make this thing converge. So we can write this. -1 is less than x minus 2 over 2 is less than 1. Multiply by 2. Add 2. And the interval of convergence is 0 to 4. So interval of convergence is 0 to 4. Now if I went back to the old-fashioned number line, 0, 4, 1, 2, 3. If you go right down the middle, that puts us at 2. And then to get to the ends, you have to go 2 spaces this way, 2 spaces that way. So from middle to end is 2 spaces. So the radius of convergence is 2. So just some terminology and how to find it. So this is the first case, in my opinion. You just get nice numbers, really. Here's the second example and the second case that I really think you're going to have to know. I've narrowed it down to 3 different scenarios. Here's scenario 2. Since we're doing absolute value, that -1 isn't really going to play a role in how we're going to solve this. We have the limit as n approaches infinity of x to the, if I put n plus 1 in for n, I get 2n plus 2, not 2n plus 1. You put n plus 1 in for the n, and then you distribute the 2. So this becomes 2n plus 2. Over, this becomes 2n plus 2, but then a plus 1, so plus 3. Whoops, I don't want to end it. There we go. So that is the n plus 1 term. Then multiply by the reciprocal of the nth term. 2n plus 1 factorial over x to the 2n. We have the limit as n approaches infinity of, there's 2 extra x's on the top, 2n versus 2n plus 2, 2 extra. What about the factorials? We can write this as 2n plus 1 factorial over, we could do 2n plus 1 factorial times 2n plus 2 times 2n plus 3. That's one way to write it out. That's like saying 7 factorial is 5 factorial times 6 times 7. It's the same thing. Now these 2n plus 1 factorials cancel out, but what's left is 2n plus 2, 2n plus 3. Now when we do the limit on n, we get x squared over infinity, which is 0. So this becomes 0 times x squared. And we want to know, when is that less than 1? For what values of x will that be less than 1? All of them. So interval of convergence is negative infinity to infinity. You take anything times 0, you get 0. That's always less than 1. The radius of convergence is equal to infinity. So scenario 1, you get nice numbers. Scenario 2, you get lots of infinities for answers because it'll always be less than 1. And here's scenario number 3. And this is pretty much out of the notes. I'm redoing the notes, but it doesn't take very long. I'm going to be done here in about 2 more minutes, and then the rest of the time will be yours. So here's scenario 3, in my opinion. Limit as n approaches infinity. The absolute value is probably not necessary here, but we'll use it anyway. We have n plus 1 factorial times x plus 1 to the n plus 1 over n factorial x plus 1 to the nth. So there's the n plus 1 term divided by the nth term. And you don't have to multiply it by the reciprocal here because we're not using fractions. The result is a fraction. All right, limit as n approaches infinity, absolute value. The top with the factorials, we can write that as n factorial times n plus 1 over n factorial. So those are going to cancel. We get n plus 1 in the numerator, and then there's an extra x plus 1. N plus 1 versus n, there's 1 extra. The limit as n approaches infinity of n plus 1 is infinity. And then we have x plus 1. We want to know, when is this less than 0? No, not less than 0, excuse me. I was thinking I need to get 0. When is this less than 1? With the ratio test, we compare to 1. And the only time that's going to happen is when x plus 1 needs to be equal to 0. So x has to be equal to negative 1. That's the only time we'll have a value less than 1. Because if you take 0.057 times infinity, that's infinity. The only time you're going to get any value less than 1 is when that x plus 1 is 0. So the rate, let's go interval. Interval of convergence is equal to negative 1 and negative 1 only. That makes the radius of convergence equal to nothing. You just have that value, and then the radius doesn't extend out to anything. So that's case number 3. So 3 scenarios today. Get that out of there. 1 is you just get some nice numbers. 0 to 4, radius is 2. Scenario number 2, it'll always be less than 1. So then you have lots of infinities for answers. And then the last case that I've seen is you just get 1 value. Now in your homework, I think you have something like this. I think it's 3. Yeah. And then you end up with this, and you have to find out what makes it less than 1. This is a brand new problem. This is right out of your homework. I had to help someone with this last period, so I thought I would get ahead of the game. When you have to solve for x here, it makes it a little bit more difficult when you got a squared term there. And here's what you can do. Here's what you should do. You can multiply by 3 because the absolute value of 3 is 3. So you get 3. Then you can actually add 1 out of this absolute value, which doesn't seem like you can, but you actually can. That's okay. And then you can square root this. You can say x now has to be less than 2. And then finally in the end you can say negative 2 less than x is less than 2. So normally we take care of the absolute value right away when we don't have a squared term. But when you have a squared term, take care of the absolute value at the very end. It's okay to do that. The problem is if you try to take care of it right away, you end up with negative 1 is less than x squared is less than 3. What ends up happening? It's like you end up with this. And you're like, well, I can't take the square root of negative 4. I can't do that. Well, to avoid that situation, you just wait till the very end to take care of the absolute value. So when you get to that, if you're still confused about it, just let me know and I'll help you out.